Hey everyone, we are live today with Nick King, CEO at Data Kinetic from a port or a harbor somewhere. Where are we calling in from, Nick?
Right now, I'm calling in from Google Cloud's event, but rather than having like a random background, I thought let's make something a bit relevant to industry. And I thought, why not? Let's look at how half, three quarters of the world's supply chain moves around, and this seemed like an appropriate background.
Well, we're going to dive into all things supply chain and AI and how you're transforming the supply chain industry. But first, before that, you have a really intriguing background, really a who's who in the industry from Microsoft to Google to VMware. Maybe introduce yourself and a little bit about your bio.
Yeah, thank you so much. So first of all, thank you for having me. I really appreciate the time. Been a big fan for a long time. So look, I came to from New Zealand to work for Microsoft on this little technology way back then, which was called cloud. And we had this thesis that people would be driving, high density compute workloads inside of servers. And at the time, we did the first open source port onto Windows, and that was really controversial at the time. At the time, we did that, became a product called HD Insight. That was probably the first like large scale parallel data warehouse map produced type product I worked on. When I went for Google Cloud, where it was very early days. I think I was like the 14th person to join Google Cloud.
Wow, that's
Worked
cool.
on Dremel, worked on Android, and then I also got the privilege to. I mean, this is gonna sound crazy. Back then, we didn't know how to make money from like AI or how to get data to the cloud. We were literally taking like HANA boxes and putting them in trucks to get data into like BigQuery. And so we built this lab for a retail, basically saying, "Hey, come with your craziest problems, and we'll AI them with what Google AI technology we have, and we'll stitch it back to our cloud." And that kind of created this concept around what is an AI application. From there, I went and worked at VMware, helped launch and build out VMware Cloud on AWS, and did the cloud transition with VMware. Went to Cisco, did 5G packet core, basically like really dense technical platform shifts. And then I realized that for me, like I'm an engineer. I've done a lot of go-to-market marketing roles, but like what wakes me up in the morning is engineering. So I went and worked for a company called Data Robot, where I was CMO there. I also ran large parts of their partnerships, and I also built a number of like what I call novel AI projects, which are AI projects we weren't quite sure if they'd work. We didn't quite know how to price them, but we're like, okay, how far can we push this concept and really look at like AI applications? And then, fast forward to a few months ago, I was just kind of looking at the market. This was before everyone like went, crazy over Chat GPT. I was like, look, I really want to get back into this. And I have this thesis that businesses need outcomes from their applications. And parts of that is AI. And a lot of the times as nerds, we over AI things and we forget about physics models and everything else. And that started a path of research for me, which led me to founding Data Kinetic. And Data Kinetic was really a simple thing, right? Like we all have data and we build dashboards,
Mhm.
but it's about taking data and taking a kinetic action from it. Like you want to take an action for what you do. And so that's really the thesis of like what I look at. Industries where the data will make an actual change to a setting for oil and gas or how you might route your logistics. It can't just be a dashboard that sits there. And so really focusing in on applied decision making with data. And that comes with consequences, right? Like if you get it wrong and you dump coagulant into an oil and gas pipeline, there's going to be some really unhappy operators if you do that. Whereas if your dashboard, the chart's wrong, okay, we'll debate a little bit, but that's not really going to crash the business. So that's where we focused very early on, but pretty pumped, and lots of interest from mainly large companies in healthcare, insurance, and oil and gas today.
That's fantastic. Well, you have your work ahead of you, especially in supply chain. One of the areas you focus on. Why supply chain? We all know it's broken, but how can AI help transform the supply chain industry? What's your thesis there?
Yeah, look, I mean, I talked to a lot of supply chain leaders, and their problems are consistent, right? How do I get more capacity, more optimization? Like they know how to do their business really well. Like I'm not a 20-year supply chain veteran, but there are things that I've learned hanging out with these people. And what I learned was, supply chains now are under increased scrutiny as to how they are maintained, both upstream and downstream. And the companies that have maintained those supply chains are also required to report on the compliance of their supply chain. So I'll give you like a really interesting example. Palm oil is involved in so many products that we have. And if you're buying 100 tons of palm oil, you want to make sure that that palm oil was like not deforested, there wasn't child labor, or it met like certain environmental requirements. Because you, as the consumer of that upstream product, needs to understand that palm oil is legit. So how do you go about validating your upstream suppliers when you have thousands of them to make sure stuff's happening? So what we figured out was we were able to automate one, understanding the upstream supply chain, go through their reporting, their files. They file these things called CSR reports, but also we could start to look at like the shipping logs, the shipping manifests, and start to combine document extraction, or even like the breadcrumb trail of these ships. And like in the palm oil example, ship leaves one country. The manifest says it has 100 tons of palm oil. It
Mm.
drives around in the ocean for a couple days. You're like, that's weird. And then it arrives in LA with 100 tons of palm oil. Turns out it left with 70 tons of palm oil. And then the supply chain in the middle of the ocean got pumped 30 tons of deforested, child labor, really bad palm oil. So
Mm.
now, if you're the person receiving that, what do? You've now got a contaminated supply chain. And
Mm.
so the way that large companies solve that today is hundreds of people, lots of audits, everything going on. And so what I realized that when you start to take these real world problems and apply, both the physics of understanding how it works and some of the techniques we have around large language models, around how we think about repeatable AI functions, we could really help drive efficiency for these organizations. And if you play this forward, 2 or 3 years time, I wouldn't be surprised if you see like an ESG compliant sticker on your toothpaste saying like this toothpaste tube, every single upstream component has been validated in this supply chain. And so there's pressures like that coming into supply chain. Advanced optimization techniques, how you forecast, very complicated. And often IT says a bunch of buzzwords, and the supply chain team's like, dude, I just need to buy 5 more trucks. Like I don't. And so that's kind of why I got into the space. A very practical, applied approach to it, and we focus on outcomes. So when we talk to customers, we're like, okay, what's the outcome? Like, we want to understand ESG compliance. I'm like, great, we'll focus on that. That's one of our blueprints. We'll run through it with you. We'll trawl the global news data. We'll do that. And for the customer, they hit a button, they configure it, and they start getting results. And we never see their data. Everything lives in their VPC. So we build it almost sort of DoD style, so it lives in their environment, and that brings a lot of confidence, right? It's a highly competitive world in supply chain. You don't want your partners sharing that data, and so we built with that in mind as well. So that's why I got into it. I would say for me, I'm really attracted to these complex problems that have some level of regulation or sophistication that requires more than just chucking an AI model out and hoping for the best.
That's fantastic. And you have a kind of a think tank research side of the business too, where you experiment with novel approaches to creating different AI functions with large language models. That must be fun. What exactly do you do there?
Yeah, there's 3 parts of that. So the first part that there was, after I've probably seen, several hundred AI applications, and I recognized a couple of things would happen. One is that no CEO has ever asked me what models inside their application, not a single one. Number two is that there's a series of functions that we tend to repeatedly do. Is it an optimization function? Are we checking for regime? Is this a survival model? Are we doing topic detection? So I recognize that there's a series of repeatable building blocks, which we call declaratives. And these declarative AI functions are able to be effectively blueprinted together to say, okay, we know you're going to build this app, therefore these are the general functions that come together, which allows us to compose the applications much more quickly. But let's say we make a jump forward in how to process large amounts of regime detection data. That same innovation can then go and replace those functions in other use cases and also provide that ability. So we have the ability to update the functions. The models that the customers are consuming can just get that incremental improvement as we learn it. And a lot of these techniques are novel, right? We're building custom neural networks. We're building different techniques on how to do like different
Mm.
types of data embedding. And so that was a declarative AI, which was really just a theory I had, which is like, why don't we build AI functions? Every language goes to this. We all started with like assembly, hacking our games and stuff. Then we went to C, then C Sharp, then Visual Basic. You sort of see how every time the model, like a language evolves, there's like a level of abstraction. And so I thought, well, the first level of abstraction has to be these AI functions. And then the second area of research that I really focus on is just looking at how you process data. And there's, we've been looking at transformers for a long time. Transformers have been really informative. Obviously, with large language models, we've seen the price of training a large language model go from
Mm.
$250,000 to $2,000 in 9 months. So the beauty of that now is like not only can you handle unstructured data, but you also can then go query like table names and SQL queries, and you can generally start querying your structured data. So the whole ETL space and the way we think about the models totally changes as well. And so in a lot of respects, the research has been about, okay, if I was to rethink what is an AI application, where would I start? And that's been the research. I sort of stopped posting on social media for 3 months just to go talk to customers and put stuff in production because there was just so much buzzwords. I'm like, you know what? Like, let's go do this for real. We've got several LLMs in production now and like real use cases. And I think, what I've also learned in the research side is that combining physics models with machine learning, with like behavioral understanding, is part of the formula. And so, buying old textbooks from old, PhD professors in oil and gas to go through their logarithmic tables to compare it to what the model's doing the right thing doesn't sound like something like a data scientist would usually do. But what I'm finding is that, guess who does appreciate that is the CEO who's like, all right, Nick, like that actually maps up with my guys in the field. So, all right, let's keep chatting.
Brilliant. So you mentioned multiple industries there. I'm really interested in healthcare and the need to transform and update the healthcare experience for all the stakeholders there. What are you thinking about in the healthcare space in particular?
Yeah, healthcare's been really interesting for me. I've had multiple experiences in different parts, and like I've been really surprised. I thought that the government was going to be really hard to work with, right? HHS, CMS, all the
Mm.
different teams. They have been amazing,
Mm.
providing data, well thought out. They've got great strategies. They're building great things there. And then you kind of get into the buyer payer relationship of hospitals and insurers and everything else. And a lot of that, there's like certain rules you have with the FDA of like who can make diagnosis, how you think about it. But there's subtleties here. Like when you're working with a doctor, the doctor calls those codes billing codes
Mm.
to bill for you, but really they're diagnoses of what conditions you have.
Mm.
So even at the very beginning, there's sort of an interrupt there of like, hey, do you have diabetes or diabetes with complications, which can have pretty big impact for how you go do billing. And then that goes through a number of processes, and then before you know it, then you've got a billing team talking to our insurance team. We're all debating codes that could have been just cleaned up front and kind of worked out. And it turns out
Mm.
that the name of those codes is the hierarchical like codes of all your conditions, which the government basically profiled all of the conditions in the health system and did decades of research. So they have a hierarchical model telling you what you're most likely to have based on a statistical outcome. So what I started getting involved with there was like, okay, we can't replace doctors. We can't make decisions. That's FDA. That's controlled. But what we can change is the way that people consume information. So if you think about, you're onboarding a new patient, you have a nurse that comes along, your average medical record might be 400 pages. They look all different. Some are hand drawn, some are beautiful. But if you've got 10 patients that day, are you going to read 4,000 pages the night before to try to figure those people out? Like, you're probably not. You're going to get home exhausted. You're going to feed your kids, and then you're going to get up the next day and do your best to be a really strong medical professional. And so what we've started to do is be able to go through and extract data from these documents, which is hard because everyone has different notations. You'd think doctors all write the same way. Nope. Every single like a cardiologist is different to an epidemiologist. It's totally different languages. Extract that, but then be able to provide the nurses and the providers with like workable summaries and sort of probabilities of like what conditions might exist. And that allows them to have a much more efficient conversation. So you have healthier patients, you have happier nurses, you got better workflow, and that once we sort of had an understanding of that, we're like, well, now we can detect fraud. And so we started looking into some of those fraud use cases. And so I think in the healthcare space, I keep being delighted with like one, how much the government is just prepared to help. And two, I think taking the time to culturally understand how healthcare providers work and like what that care life cycle is, has made a really big difference in kind of going there. And so that's why that healthcare solution came about. Ironically, because I use declarative models, everything else, the actual AI underpinning it, very, very similar. And so, you still compose the application, you put it together. And so I think for me, it's about finding complex problems, usually in regulated industries, where we can really go and help make real outcomes and deliver something that's, usable. And the next question people usually ask me, like, Nick, is this a pro serve company? What are you doing? Are you building a platform? Like, what is this thing? And for me, like, I think building a catalog of outcomes is really important. But the last mile of like, how do you make this so it gets consumed and used is really important. And luckily for us, like in the example I talked about for the nurses, we basically generate an email that they print out because nurses don't want tablets. They want to have and they have a daily email with 10 sheets with some questions to tick. And we just, that's the last mile of delivery. We help them deliver it. And often once the team has trust in the data, they often go build it through integrated systems. They don't want like another screen, another app, another QR code. And so, we'll tackle the hard problems, but the goal is really to look after a series of predictable outcomes that people, that businesses consume that, maybe not a lot of other companies just won't touch, and do so in a highly secure and trusted way.
Brilliant. Well, here's to wishing you success in that space. There's been so many false starts, misstarts with AI in healthcare, going back to,
Yeah.
gosh, Watson and that whole challenge, getting the data, getting useful outcomes there. So much needed. Let's talk about platforms. You're at Google Next in San Francisco right now. Any big insights or takeaways you want to share? And also, how are you working with both Google and others?
Yeah, so look, I just love what's happening right now. We're seeing all of the cloud providers bring in primitives, right? So that many of the tools that we would have to like sidecar, 6 months ago or even a year ago with transformers, are becoming part of the platform, right? And that's making a huge difference to just how they're operating. So I'm really enjoying just what Google's doing, how they're focusing, the concept of a model garden where you kind of can have these trusted models. There's a lot of vectors where things can go wrong, and I think Google, Microsoft, AWS, even Databricks and Snowflake, like everybody's focused on getting to what I'd call like a consistent set of primitives. So vector stores, how they think of chaining agents together, what an agent framework looks like. I'd put Palantir in that list as well. I think they're doing some amazing stuff there as well. And look, what I realized is that, I've sold and built platforms, through my career, as I was sort of saying. When I go talk to a customer, he doesn't want me to say like, "Hey man, can you get IT to like chuck this thing in and put that thing out?" I'm like, "Look, you've made your choice." And like, I don't want to go build things to compete with Databricks or BigQuery. They make great tools that scale really well, and they want to work with folks like us that like help that work. And like the organization, they're familiar with those tools, so we remain platform agnostic. And so the way that kind of works, we have effectively an orchestrator. The orchestrator basically can choose how to like, what choices you have. There are some configurations where like, we may need higher computes. We might request like certain, H100 cards for some bits and pieces. And like, it depends how specialized you are. And, the response from the cloud providers has been good. I think for most of them, we're all talking buzzwords right now, right? And like, I could geek out for hours. We could talk about all the different pieces. And I'm trying really hard to sort of stay above that and look at outcomes. And then, let the teams work with each other and figure out, okay, like, is it a Google decision or an AWS decision or an Azure decision? But all of them are very focused and super helpful. And I'm just pretty excited to see how like the partner ecosystem evolves as well, right? Like, I think a lot of the like as we watch like ChatGPT add an enterprise functionality, as we see this evolve, it's going to keep pushing us to think differently. But my advice to most people is like, look, 6 months ago, large language models, $250,000 to train one. Today, $2,000. So like, don't rush out there and make these decisions because it seems like a great, cool project. be very selective in where you get good. So get good at embeddings, get good at indexing your embeddings, get good at agent delivery, get your policy together, because the primitives will be there in 6 months. And and then that way, to get applications actually applied in production, I think many people are making good progress there. I really like what Databricks is doing with MLflow and kind of having this concept of a model gateway. I think that's a really smart approach. I would expect model routers to come pretty soon, where you sort of say, you got a code gen router and a translation router. I just think we're going to start seeing much more specialized, like, agents of excellence and models of excellence. And so I want to just shout out, this Google event's amazing. The Databricks event was amazing. They're putting real money in to try and get us to build stuff. And I think the market's still hard, right? I think there's still a requirement to bridge the gap between nerd talk and value. That's on all of us to fix. But yeah, there's sort of no holding back. And I think for all of us, the beauty is, every 2 weeks there's something new to learn. The bad thing is like, if you just keep learning every 2 weeks, you don't baseline your knowledge. And so what I usually recommend is like, okay, choose a model, Llama 2, just focus on that. 6 weeks, that's it. And then once the next thing comes along, focus on that and just get that level of like technical depth before you move on to the next buzzword.
Fantastic approach. So what do you want to be when you grow up at Data Kinetic? You want to be the Accenture or McKinsey of AI? Is that maybe a vision, or what do you see over the next couple of years?
Like, I actually work with a lot of those folks. Like, I help them build out models. They take our blueprints and apply them where they may not have the same skills to deliver. If I'm honest, I want to build cool stuff with cool people. Like, if I'm going to be like, but no, like, to be really honest, look, I think we've had 4 generations of AI application transformation, right? We had MapReduce with big data. We had kind of the AutoML tools revolution. We kind of saw a number of platforms. Now we're in the 4th wave with these large language models. We've never cracked delivering enterprise value in a predictable way. IT goes and says a bunch of stuff, and most of those people leave that room and be like, I don't know what that person said, but I know it's going to cost a lot of money. And my vision is like, look, let's get some real use cases into the world, and let's rethink what actually is an AI application, if one even exists. And let's build that catalog that gives people access to that. And if we can, as Data Kinetic, provide that catalog and provide that thinking and put that research in, and even help people learn how to do this stuff, so they can go from like no idea how to do gas lift optimization to being, having a peer-reviewed gas lift solution, I think that's a big jump, right? And so I think there has to be that level of abstraction. And I do think that, for us, in 5 years' time, 10 years' time, we can't be like, still at this like low level trying to make these models work and grinding our way through it. And so my vision is like, let's build the abstractions, let's work together, let's share the knowledge and build a catalog of really impactful use cases where like the actual operations team will be like, hey, I'm just going to click this button and do these next things 3 or 4 times. We're going to be good. And that's the level of confidence I want to see come out of these AI applications. Because today, that's not what you hear. That's not what you hear.
Well, it's exciting. I think someone's calling. The next ship is coming in, I think, behind you there.
Yeah.
So we may have to move along. But you're based in Austin. You're in San Francisco now. What's next? What are you excited about over the next few weeks? Any events or travel or otherwise?
Yeah, so I'm heading to a digitization oil and gas event in Houston in a few weeks. We're going to announce a number of oil and gas suite applications there. We're also talking with bringing out a number of healthcare use cases as well. And so for us, we just want to get out there. Like, I'm staying as close as I can in industrial use cases and in those spaces. And then we're also looking at some autonomous agent like experiments that we'll be sharing some research there as well. But for me, it's like, get in the field. I got my like oil and gas cowboy boots now. So like, we're doing the real thing. And, everyone else listening, like, look us up. We're always happy like to nerd out and share stuff we're learning. I'm really open about like what we're working on, but like, even if you're getting stuck and you're like, hey, I've got a question, how might this work? Those that know me know that, for us, that knowledge sharing is just part of the community, right? Like, we're all in this together. It's hard. We spend hours and hours and stay up late trying to make this stuff work. And so just a huge shout out to everyone out there that's trying to make this work. And even just for your help in the community to like bring it all to light for us.
Well, thanks so much for sharing all your insights and taking time out of unloading there at the dock. And, much appreciated. You're doing fantastic work. So I look forward to following your progress. And thanks everyone for watching. Reach out to Nick and have a chat. Any questions, comments are welcome. All right.
All right.
Thanks everyone. Thanks, Nick.